Okay, hi guys, so we'll be continuing on seeing examples when more than one element in the compound changes their oxidation state. So let's continue on the same. So we have CO2s, okay, changing its oxidation state from, or rather going to first Cu plus 2 and SO4, SO2 plus SO2. So here copper is in plus 1 state going from plus 1 to plus 2, and Cu is in minus 2 going from minus 2 to minus 4. Okay, so number of electrons released by copper would be 1, and number of moles of CO2 present, copper present in the compound is also is 2, plus oxidation state of sulfur changing from minus 2 to plus 4, hence number of electrons gained is 6, so n factor here is 8. Next we have FeS2 going, when on heating, going from FeS2 to Fe2O3 plus SO2. So Fe oxidation state is plus 2, S is minus 1 going to plus 3, and S is going from minus 1 to plus 4. So oxidation state n factor would be number of electrons released by Fe is plus 2 to plus 2, plus 2 to plus 3. Number of moles of Fe in the compound is 1, plus number of electrons released by S would be 5, and number of sulfur atoms present in the compound is 2, hence the answer would be 11. Okay, let's see another example where we have Fe FeNO3 whole thrice giving Fe plus NO. Okay, so Fe going from plus 3 to plus 2, and NO3 going from, so N in NO3 going from plus 5 to plus 2. This is plus 2. Okay, so n factor would be number of electrons accepted here would be 1 by 1 mole of Fe, plus number of electrons accepted by 1 mole of N3 would be 3 multiplied by 3, n factor would be 10. Let's see another example wherein we have AS2 S3 going into ASO4 3 minus plus SO4 2 minus. So AS here is in plus 3 state. How am I calculating this? So suppose the oxidation state of AS is X here, number of atoms of AS present is 2, plus what is the oxidation, what is the charge on S, minus 2 multiplied by 3 should be equal to 0, as the compound should be overall electrically neutral. So X comes out to be plus 3. So in some basic high school maths, I am calculating the same. Okay, so AS goes from plus 3 to here. Oxidation state of AS is plus 5. How am I calculating it? Again, just do the same in which you have been given. You have to calculate the oxidation state of AS, so let it be X, plus what is the oxidation state of O, minus 2, and number of atoms of oxygen present is 4, equals to minus 3, as the charge on the ion is minus 3. So X would come out to be minus 3 plus 8, so X would be 5. So this is in 5 state, and this again similar manner, oxidation state of S can be calculated as 6. So S is going from minus 2 to plus 6, and AS is going from plus 3 to plus 5. So number of electrons released by AS is 2 by 2 moles of AS in the compound, and number of electrons which S released in the reaction would be going from minus 2 to plus 6, which would be 8 multiplied by 3, which is the number of moles of S present in the compound. So total number of n factor would be 4 plus 24, which is 28. Let's see another example. We have BaSCN whole twice going into BaSO4 plus HCN. Okay, so Ba is in +2 state here. It again remain in the +2 state here, so no change in oxidation state. What about SCN? So for SCN we have something like SO4 here changes its so let's look like this. So we have SCN going from -2 state here to +4 state here, +6 rather, +6 state here, and Cn minus is actually going into from +1 to so if you look at the Cn will be going from +1 to -1, as here the charge on Cn should be +1, so as the overall charge on SCN whole twice is -2, hence Ba +2 is getting attached to SCN -2. So here the charge on Cn would be whole Cn is +1, and here the charge on whole Cn is -1. So this is getting reduced and this is getting oxidized. So number of N factor would be, for the oxidation state it would be 8 electrons are released by sulfur atom, and total number of moles of sulfur in this compound will be 2. This is getting oxidized, and what is getting reduced? Cn is getting reduced from +1 to -1, so 2 into 2. 2 is the number of electrons accepted by Cn and number of moles of Cn, and the compound is again 2, so its answer would be 16 minus 4, which would be 12. Okay, so now let's see another important example. I hope you got this example. This is for oxidation and this is for reduction, hence you have to take the minus of difference of 2 and take the modulus. So if we have FeS2 Fe2S3 getting oxidation to form FeSO4 plus SO2, so here Fe is going from +3 to +2, and sulfur is going from -2 to, at first it is going to +6 here and +4 here. So N factor would be, Fe is getting reduced, so for Fe we can write that number of electrons gained by Fe. So first I am writing the reduction step, minus will be writing the oxidation steps, okay, and taking the mod of the difference. So in reduction we are going from Fe plus 3 to Fe plus 2, so number of moles of electrons would be gained by Fe would be 1, and how many number of moles of Fe is present in the compound? 2. Then for S3 we can simply write that for S3 we have that the number of 2 moles of S3 are getting 2 moles of S3 are getting into from -2 to +6, and 1 mole of S is getting from -2 to +4. So 2 moles of S3 are getting from -2 to +6, so 8 electrons plus 1 mole of sulfur getting from -2 to +4, which is 6. Okay, so this is nothing but N factor is 2 minus 16 minus 6, which should be 20. 20 is the N factor here. I hope you get the logic that why we are calculating, where we are putting 2 and 1 here, because 2 moles of S2 or 2 moles of S are going from minus 2 to plus 6 in this compound, and 1 mole of sulfur is going from minus 2 to plus 4 here. Okay, so this is the thing here which has to be dealt with caution. So with this we come to the end of this lecture. In the next lecture we'll be seeing more examples on the same. Okay, so till then, good luck and goodbye.